BWR, and RBMK nuclear reactors. Imagine a world where electricity powers everything around us, from our homes to hospitals. Now, think about how these huge amounts of energy are made safely and efficiently. That's where nuclear reactors come into play. They are complex machines that use atomic reactions to generate electricity, but not all reactors are built the same. Today, we're looking at three main types: pressurized water reactors, boiling water reactors, and RBMK reactors. Each has its own design, strengths, and safety concerns, especially when it comes to accidents or disasters. Let's start with pressurized water reactors. These are the most common in the world. They use ordinary water as both a coolant and a neutron moderator, which helps control the nuclear reaction. The water inside the reactor is kept under very high pressure, around 155 atmospheres, so it doesn't boil even at temperatures near 300 degrees Celsius. This hot, pressurized water flows through the core, absorbing heat from the nuclear fission process. It then passes through a heat exchanger called a steam generator, where it transfers heat to a secondary water circuit. This secondary water turns into steam, which spins turbines to produce electricity. The key safety feature here is that the radioactive water stays in a closed system, so the turbines are never exposed to radiation during normal operation. Next, we have boiling water reactors. These are a bit simpler in design. Instead of keeping the water under high pressure, they operate at lower pressures, around 70 atmospheres. Because of this, the water in the core boils directly inside the reactor at about 285 degrees Celsius, creating steam right there. This steam then goes straight to the turbines, which makes the design more straightforward and less costly to build. But it also means the turbines are exposed to radioactive steam, so they need special shielding and maintenance precautions. BWRs are flexible and can adjust power output quickly, but operators must carefully control the boiling process to avoid instability. Now, let's look at the RBMK reactor, which is quite different from the other two. It was developed in the Soviet Union and is mostly found in Russia and some former Soviet states. It uses graphite as a neutron moderator and water as a coolant. The reactor core consists of many vertical pressure tubes filled with uranium fuel, surrounded by large blocks of graphite. This design allows for online refueling, meaning fuel can be replaced without shutting down the reactor. The water in the tubes boils at about 290 degrees Celsius, similar to a boiling water reactor. But here's the tricky part. The RBMK has a positive void coefficient, meaning if the water boils away, the reaction can increase rapidly, causing dangerous power surges. This design played a role in the Chernobyl disaster in 1986. The RBMK lacked a robust containment structure, which meant radioactive material could escape more easily during an accident. Its control rods also had design flaws that contributed to the explosion. While safety improvements have been made since then, the RBMK's inherent vulnerabilities still make it a risky design. In summary, these three reactors show how different approaches to water, moderation, and control impact safety and operation. Pressurized water reactors are the most common and safest, thanks to their high-pressure systems and containment structures. Boiling water reactors are simpler but expose turbines to radiation. The RBMK, with its unique design, has a history of serious accidents, reminding us how important careful engineering is in nuclear safety.